Welcome. In this video we'll be analyzing more on sine and cosine. Let's take a look at our example. Let theta represent the angle between the x-axis and the ray with endpoints 0, 0 passing through -4, 4. Find sine of theta and cosine of theta. So the first thing is to draw an actual sketch so we can understand what's going on. Well, first of all, here let's pretend we have our quadrants. And let's say that here we have the origin, so that's the point with coordinates 0, 0. And let's go to the point -4, 4. So here's -4 on the x-axis and then 4 on the y-axis. So we have the point -4, 4. Now, we're going to have an actual ray that passes through this particular point, -4, 4, and has an endpoint of 0, 0. So here's your endpoint, and it's passing through that particular point. Now, the nice thing here is that we're actually looking for the angle specifically between the x-axis and the ray. So this is the angle of interest here. That's your angle theta. One more nice thing is the fact that here we will be dealing with a right triangle. And if you notice, the length here is 4 units and the length here is 4 units. Okay, so this is an actual special right triangle. We have a triangle in which one side is 4 units and the other side is 4 units. This is a 90-degree angle. So we sketch this one where here's theta. We actually know that this is a 45, 45, 90. Okay, because if theta is across from this side of measure 4, then this angle across from the other side that measures 4 is also theta. And by the fact that the 3 interior angles of a triangle add up to 180, we know that this is 45 degrees, this will be 45 degrees, and this will actually be your 90 degree, and that gives you the total 180. Well, if you remember from special right triangles, we know that this will be the legs, and this is your hypotenuse, and the hypotenuse is always the length of the leg times the square root of 2. You can actually prove this by using Pythagorean theorem as well. Now, why is that important? Well, keep in mind the following. Recall that x is equal to r times cosine of theta, and y is equal to r times sine of theta. Our ultimate goal is to get the cosine and the sine by itself. When it comes to x, your x coordinate was -4. So we have -4 is equal to your r, which in this case it's this radius, which is 4 times the square root of 2 times the cosine of theta. On the other hand, your y coordinate was 4, so we have 4 is equal to the radius, which is 4 square root of 2 times sine of theta. Now, our ultimate goal is to get the cosine by itself and the sine by itself. So we need to solve for those. In this case, since cosine is being multiplied by 4 times the square root of 2, I'm going to divide by 4 times the square root of 2 on both sides. Now, this cancels, and that leaves you with cosine of theta being equal to -4 over 4 square root of 2. Obviously, we can cancel the 4's, and that leaves you with -1 over the square root of 2. Okay, so we can say cosine of theta is equal to -1 over square root of 2. But we want to rationalize the denominator, so let's multiply by the square root of 2 over the square root of 2. And that gives you that cosine of theta is equal to -square root of 2 over the square root of 2 times 2, which is 4. This is a perfect square. So we can say that cosine of theta is equal to the negative square root of 2 over the square root of 4, which is 2. And that gives you your actual value for cosine of theta. Now, along the same way, we can figure out what is the value for sine. So we want to solve for sine here. To do that, let's go ahead and divide both sides of the equation by 4 square root of 2. Notice this cancels with this, so we end up with sine of theta is equal to 4 divided by 4 square root of 2. Again, the 4's cancel, so you can simplify this to 1 over square root of 2. Well, this implies then that sine of theta is equal to 1 over the square root of 2, but we want to rationalize this. So let's multiply by the square root of 2 over the square root of 2. So that implies that your sine of theta is equal to 1 times square root of 2 becomes simply the square root of 2 over the square root of 2 times 2, which is 4. And that's a perfect square, so we can simplify this as a square root of 2 over 2. Okay, so that implies that your sine of theta is equal to square root of 2 over 2. And notice we were successful at finding the value for cosine of theta and the value for sine of theta. So I thank you for watching this video. You have a wonderful day. See you soon.